Okay, so on this next one, when I want to find the values when the particle is at rest, of course that means that my velocity has to be 0. So I'm going to take that velocity, excuse me, and set equal to 0, which means I get sine of t equals 0. And of course I know that sine is equal to 0 at 0, and again at pi, and again at 2 pi, and 3 pi, and so forth. And so if I want to write that, I can write k pi, but I have to also note that k, this is the notation for an element of. It's actually a lot smaller than that in textbooks. And it's an element of the natural numbers being 1, 2, 3, 4, 5, 6, 7. So fancy notation is all that is. Last one, I swear! Okay, so we have a ball thrown upward, and it gives me a speed, an initial speed. So remember, speed is absolute value of velocity. But it's going up, so velocity would be positive anyways. So here's what I know about that. When time is 0, velocity is 48. And then it also gives me another little Blue's Clues. So I have 432 feet above the ground. So again, when time is 0, but this time that's position is 432. So I don't see any more Blue's Clues, but instead I see some questions that it asked me. So I'm going to call this one A. So I'm supposed to find its height t seconds later. So it wants to know height, but height would be position. Okay, so that would be, and since it says t seconds later, I know my answer is going to be in terms of t. And then the next question it asked me is, when does it meet its maximum height? So let's see, maximum height, that would have to do again with position. Let's see, how can I get maximum position? Ooh, I know. If I know the position formula, to get the max, I would take the first derivative and set it equal to 0. Oh, in other words, I would get velocity and set equal to 0. Okay, I'll come back to that. So I have a plan with my clue. And then last but not least, when does it hit the ground? And of course it hits the ground when the position is 0. Okay, so all of these have to do with position, and I currently do not see a position formula. Nowhere does it tell me what S of t equals. And it doesn't tell me what V of t equals, so the only thing I have that I can start with, that I know because it's a constant, is acceleration. So I do know, now this was feet, I know that acceleration is negative 32 feet per second squared. So of course if I take the antiderivative of that, I'll get velocity. Oops. Which is negative 32t plus c. And I go, that's the general solution for velocity. Is there a way I can get rid of that c and make this more specific? And I say, why, yes, there is. I have a Blue's Clue up here, remember? So I'm going to go back and use that Blue's Clue. And so I can plug in 48 and the 0. And I'll find out that c is 48. So now I know the specific velocity function is negative 32t plus 48. So I go, I'm doing good so far, but I got to get to position. So that means I got to take another antiderivative. Let's erase some of this. So now I'm going to take the antiderivative of velocity, And remember, when I take the antiderivative of velocity, it's going to give me the position function. Oh my goodness. This takes a little while, but I'm excited that I know what I'm doing. And so I'm going to power up. So that'll be a t squared divided by 2. And then a 48t. And then a plus c. And again, I need more specific if I'm going to be able to actually find the specific s of t. And so I have this information here. So 432 is going to equal, now if I plug 0 in there, that'll be 0 plus c. So c is 432, which means my position function, oh, that's what they wanted for A. Go to part A, is negative 32, oh, let's do 16, right? That reduces. So negative 16t squared, remember that came from down here, plus 48t plus, and now I know the c value is 432. So there's the part A piece. So then when I get to part B, remember I wanted to take velocity and set it equal to 0. And of course I already had velocity down here. So I'm going to take negative 32t plus 48, set it equal to 0, and when I do, I get t equals negative, what'll be negative 48 over negative 32, which reduces both by 16, so I get 3/2. And remember, that's 3/2 second because it's time, and it wanted to know when, so at 1.5 seconds. And then for part C, I wanted to know when does position equal 0. So I set the position equal to 0, and then I factored, and oh boy, this is not going to, right, well, I took out a negative 16, but this isn't going to factor, which means no way, I have to use quadratic formula. Preposterous, right? So you can double check all my math. And remember, I get 2 answers from this, but one of them is going to be a negative, so time can't be negative. So I only get to keep the positive, which turns into about 6.91 seconds. Double check and make sure you can actually get that out of your calculator. Remember, when you put this into the calculator, it is necessary that you use parentheses around the top or you'll get the wrong answer. Okay, I will see you tomorrow.